So, hi guys, hi everyone. My name is Deepanshu. I'm one of the co-founder and director at PyNet Labs. We have Mr. Chirag with us, who is your instructor and who will be your instructor for this batch. We'll do the introductions once again, and we'll wait for more people to join in. Meanwhile, if you want to, share and if you want to save your time, hi Aftab, Digambar, Govind, Krishnamurthy, Madhvi, Mohana Krishna, Parikshit, Shakti Mohan, Shivashi, Sunil, Veera, Shiva, Vikhyat. Okay. Hi guys. Hi ANK. ANK is it Ankit or something? Hi everyone. So before we begin, we'll take another, let's say, 4 or 5 minutes to begin. Let other people also join. Meanwhile, could you raise a question in the chat box that what is your expectations from this? Maybe this 1 hour that you're investing here. So if you could just quickly write that what you are looking for, what answers you're looking for. See, we'll go for a technical demo as well. Means, I'll speak for maybe 5 minutes and then Chirag will go for a technical demo. And meanwhile, if you have any questions, I'll keep answering in the chat. And after the session also it can be answered. Yeah. So if you have any questions, any expectations you have from this 1 hour session, please share here in the chat box itself once. Sure, that's a good question. You expect us to share level of knowledge and career growth impact you can create for us. So quickly, ANK, what's your background like? Where you're working right now, or you're a fresher right now? If a fresher, then what kind of domain you're from and what you have done? And if you could just give me a brief about that as well. BTech, you're a fresher in BTech right now, and which batch you're graduating? Sure, Ali. All right, perfect. All right. Ari, as an MBA, why do you want to move into network domain? Any particular reason you want to move into network domain? Hi, Imran, you have raised your hand. Could you please put your query in the chat box once? Hi, Gulista, welcome. Hi, Aftab. Okay, BA. But what's your expectation, Aftab, from this session? Gulista, what's your expectation from this session today? All right. So I think most of the participants have joined and you have also invested your 4 minutes. So we'll start now. So quickly, I want to just give you a brief about PyNet Labs. PyNet Labs is a training company, which mainly a corporate training company. We also have placement guarantee programs. So how the placement guarantee program started, I'm sure some of you might have visited or watched my videos, or if you have not watched, that's fine. So we are primarily connected with a lot of corporates in terms of our corporate training programs. We are also connected with their L&D, HR, and a lot of different teams. And there are a lot of requirements that keep coming to us. If you're already there in our Telegram group, or I'm not sure if you're there in the Telegram group or not, you can check the Telegram group or YouTube channel for the latest placement records as well. Now, as you know, we were getting a lot of requirements from the corporate. We started this job guarantee program last year. Till now, I think around 75 to 100 people have already joined this job guarantee program. Some are joining this week for there are two batches upcoming 27th, which is a Saturday batch, which is a weekends batch for you guys. Another is 29th, which is a weekdays batch for you guys. Okay. So I'll not get into that right now. We'll start with basic topics, any basic topic that you want to start for CCNA. And then we can take your questions, any questions related to your placements for your career growth or anything related to that. You can share your maybe you can ask me to unmute yourself. I'll unmute you. You can share your question and I'll be able to answer your question as well. Hi Chirag. So welcome Chirag. And I think Chirag is with PyNet Labs from since very beginning of PyNet Labs only. He's been teaching CCNA, CCNP Core, CCNP NRC. He's also teaching network automation to few of our corporate clients as well as few of our international clients as well right now. And overall, Chirag has been delivering job guarantee program batches from last I think one year almost since we started these batches. And overall, Chirag is with PyNet Labs since the beginning of PyNet Labs itself. Yeah. Over to you, Chirag. We can take up any topic, Chirag, today for the session for just a quick demo session. We can take up any topic, and just we can help everyone to learn something new. Yeah. Sure, Gulista.
Thank
I've
you,
noted your.
Dipanshu. Yeah,
Sure.
thank you
Okay.
for the introduction. Hi,
Sure.
everyone. My name is Chirag, and welcome to PyNet Labs. Welcome to this demo session for the CCNA 200-301 program. And in this session today, we'll be trying to understand some basics of networking. We'll try to see how network works actually. Then we will also talk about CCNA, how we take things ahead in the CCNA. when it comes to the CCNA training, how we keep such things there. So let's get started quickly. Let me first of all quickly tell you what exactly is the content of the CCNA training and what you can expect after learning CCNA from yourself. So when we talk about CCNA content is divided in 6 categories. We can say the official categories which we observe under CCNA is network fundamentals, network access, or in simpler words, we can say layer 2 operations. Then we talk about IP connectivity, where we discuss layer 3 operations. Then we talk about IP services, where DHCP, QoS, all such things get into picture. Then security fundamentals, we try to understand how we can make sure that the network is secure by ensuring some of the configurations of security related protocols. So we talk about such things there. And lastly, we get the introduction to automation and programmability. This is going to be the major topics, or we can say these are the major categories under which we will be talking about multiple subtopics. When I talk about the very first one, network fundamentals, this is for everyone who is new to networking. So when we talk about CCNA, this is an associate level program. We cannot expect any sort of understanding from you guys. But if you are already having some experience with networks, then that's great. Otherwise, even if you are not having any experience, even if you are not aware of how networking works, then network fundamentals is something which will prepare you for the further topics. Here we talk about all the basics, like what is IP, what is MAC, what all components of networks are there, how networks actually operate, what is happening behind the devices, what are the networking models, all such things we'll talk about in the network fundamentals section. Once we are good with that, we start playing around with layer 2 technologies. We talk about switching concepts here, like VLANs. We talk about how inter-VLAN routing works. We talk about multiple other protocols like STP. Then under IP connectivity layer 3, we discuss about things related to router, how routing protocols work. Like you must have heard maybe about RIP, EIGRP, OSPF. So we get in the details of all these protocols. We try to learn about each of the protocol in detail and try to understand their use and their features. Then once we are good with the switching and routing section, then we start discussing about IP services. Under IP services, we get to see things like DHCP, which is the dynamic way of assigning the IP address to end devices. Then we talk about SNMP, we talk about network time protocol, NTP, we talk about NAT, we talk about quality of services, multiple other things. Security fundamentals, which is the next category. This is something which provides you the ability of ensuring that your network is secure, because in your network there can be multiple types of threats which can happen, right? So you need to make sure that everything which you have configured or everything which is there in your network is secure. So we try to learn about some of the features which we can configure, like port security, ACLs, to ensure that some sort of security is also there in my network. Then automation and programmability, there we get to see how automation is something which is getting into the network and how it is helping us in multiple ways to minimize the efforts which we need to put in order to make some sort of configurations. So this is a CCNA program where you will get to know about each and everything, and you will get a good idea about the various aspects of the networking. And today we will be discussing something related to IP connectivity. So we'll try to look at some IP networks. We'll try to understand how the networks work, what all different classes of IP addresses are there. So we'll try to see how those things work. by ensuring that we are discussing every topic from very scratch, so that everyone here can get a little bit understanding of that. So let's get started. Let's talk about the IP protocol. So first of all, when we talk about IP addresses, you all must have like somewhere observed some sort of IP address. So any IP which you get in your mind, you can put in the chat box. What do you think? How does a IP address look like? Just let me know in the chat box any random IP which you might have in your mind. 192.168.0.1, 10.116.35.61. Perfect. So these are the IP addresses. 192.168.0.1. Now, when we look at this IP address, there are few things which we can understand out of it. The first thing is that I can see there are 4 groups, right? So first of all, these groups, or we can say these particular sections, will be known as octets. Why do we call it as octet? Because it is made up of 8 bits. Like we use the mathematical terms hexagon, pentagon. So anything of 8 is octet, which is basically we are referring to here. We have 4 octets. That means the IP address is made up of 4 octets having 8 bits in each. That means the total size of my IP is 32 bits. Now these IP are assigned to us by an organization called INA, Internet Assigned Number Authority. The INA organization takes care of providing the IP addresses to multiple ISPs. Then these ISP provide them to organizations and to the end customers like you and me. So today we will try to understand what all classes of IP addresses are there and how different networks work together. So when we talk about INA, INA has provided 5 classes for IP address. We have class A, class B, class C, class D, and class E. Class A ranges from 0 to 127. Class B goes from 128 to 191. Class C 192 to 223. Then class D is there from 224 to 239. And class E is there from 240 to 255. But the question is, how will I identify that whether my IP is belonging to class A, class B, class C, class D, or class E? All you need to do is you need to look at the value of your first octet, which is this one, 192. So 192 is the value of my first octet. Now I need to find out that out of the 5 classes, in which class does my IP fall in? So I can see that class C is from 192 to 223. That means this IP belongs to class C. Now a detailed discussion on the segregation of these classes and how they work we'll be doing in the training program. As of now, we will be talking about only the main topics which can help us in understanding why the routing is required. Okay. So at any point you think you are not able to catch up with the discussion, just put it in the chat box and I will explain the section from very detail. Now we are clear that this IP belongs to class C. So for each class, we have a segregation of network and host bits. For example, when I talk about class A is segregated like this: n.h.h.h, where n represents the network bits, h represents the host bits. Class B goes from n.n.h.h. Similarly, class C n.n.n.h. Now guys, we have learned that in one octet, how many bits are there? There are 8 bits, correct? So if we have one network octet, that means how many bits do we have of network? 8 bits, correct? Similarly, if I have two network octets, 8 plus 8, so I can say I have 16 bits. Then if I have three network octets, that means 8 plus 8 plus 8, 24 bits. But what about these two classes? So these two classes are not something which we can use for providing the IP addresses to end devices. These are reserved. Class D is reserved for multicasting, which is a type of communication which we learn in the CCNA program. Then class C was reserved for research and developments. So we basically are just allowed to use the IP addresses from class A, B, and C. So even if you try assigning some IP from class D or class E, you will get the error there on your device. So we have these three classes out of which we can pick up the networks. Okay, that's cleared. So let's talk a little more about the segregation of network and host bits. So let's say I have got two IP addresses. I have 192.168.1.2/24, and then I have 192.168.2.1/24. Now I want to find out that whether these two IP are from same network or from different network. So what we just need this value, slash value. This slash value represents the number of network bits of your IP. So when I can see I have 24 here, then that means this is the network, this is the network, this one is the network, and this is host. Network, 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 host. Correct? Similarly, if I have some IP like 150.10.1.5/16, then in this case, the first one is network, second one is network, this is host, this is host. So when you want to find out, guys, that whether two IP belong to same network or whether they belong to different networks, all you need to do is you need to match the values of their network bits. So let's try to match the values. This is my network bit, this is my network, this is my network, and this is my host octet. Similarly, H. I'll match the values 192, 192. It's correct. 168, 168. Then I have one here and two here. So if the values are not matching, that means the IP is not a part of same network. That means this is a different network, this is a different network. Make sense, guys? Is it clear to everyone? Give me a yes or no in the chat box. And if it is clear, then let me know that whether 192, 168, 1.10 and 192, 20.5.10, whether these two IP are from same network or not. They are not from the same network. Let's try to understand why. We have written /24. /24 means 24 divided by 8. That means 3 octets. So this is network, this is network, this is network, this is host, network, 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 host. Correct? Now we will match the values 192, 192, 168, 170. These two values don't match. So the network section of both the IP is not same. Hence, we can say that this and this are from two different networks. Clear, guys? Now let's take one more example. It is 10.1.5.7/8 and 10.6.1.2/8. Now tell me whether they are from same network or different networks. Are they from same? Yes or no? Absolutely correct. They are from different network, correct? So when we have two devices which are from different network, what do we use? We use something called as router. Now we have heard a lot about router, but we don't actually know what router is exactly used for. So if two devices are in different networks, then we need a router. So do we need a router here in order to make these two IP communicate? Absolutely correct. So we use gateway to communicate with two networks, and that gateway is basically your router. So since these two IP are from same network, do I need a router, guys? Come on, guys, let me know. No, actually, I don't need a router. I can put a router there in my topology, but I actually don't need it. Why? Let's try to understand again. In this section, I have written /8, correct? /8 means the only first octet is network and the remaining is host. N.H.H.H. Now, N and N, both the values are matching. That means both the IP are from same network. When we have two PCs which are in same network, so do we need a router to make them communicate? No, no need of router, we can say. No need of router when devices are in same network. Then if, for example, I talk about 192.168.5.10 and 192.168.6.10/24/24. First of all, tell me if they are in the same network or different network. Absolutely correct, Aftab. So if the N match like the values for N is matching in both the IPs, then we don't need router. If it is not matching, then we need router because then it is a different network. So this is a different network, right? I can see your responses. Why is it different? Let's try to understand. We have written /24. That means 3 octets are in the network section. N, 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 H, right? 192, 192, 168, 168, 5 and 6. So these two values don't match. That means these two IP are in different networks. So whenever your IP are in different networks, what we need? The device called router. Make sense, guys? So if I have a PC which is configured with first IP, which is 192.168.5.10, and a PC which is configured with 192.168.6.10, then what I need is I need to connect them to a device called router so that my router can transfer the packets from first network to the second network. If I connect these two devices directly, if I don't put them through a router, if I put a direct connection between these two PCs, then this communication will not work. Is it clear, guys? So you guys will tell me now that 195.10.1.6/24 and 195.10.1.56/24. These two, will they need router or not? Right? So you need to tell me that whether they need router or not. Just simply tell me yes or no. Do they need router? No, they don't need, right? Why? Because they are from same network. If I say 200.10.5.6 and 200.11.1.6/24/24. No need of router here. What about the second example, guys? Do we need router? Different networks? Yes. So since they are different networks, so we need router. Yogi and Yogi, yeah. So you have written no. Let me explain this to you again. We are saying that whether these two IP belong to same network or not. And as I have mentioned, how do we identify this? We identify by looking at the networks, right? The network values. So when I see /24, that means 1, 2, 3, 3 octets are network, and the last one is host. Then network, 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 host. Correct? Now When I look at the values, 200 is matching in both the IPs, but 10 and 11 don't match. 5 and 1 don't match. That means this IP and this IP are from different networks. And whenever two IPs from different networks wants to communicate, we need router. Clear? Is it clear to you now, Yogi? And others also, if anyone was having any queries there? Perfect. Great. So we will try some example now. We will try to look at topology into a simulator called Packet Racer. So Cisco is providing this simulator where you can practice your networking labs. How to download this, how to use it, I will be explaining it in a very deep manner in the training program. So we will perform all our basic labs on the Packet Racer. And today also we'll try to make two PCs from different network communicate with each other using a packet tracer lab. But let's try to see how we will create this lab. What I will do is I'll take a PC and another PC. I'll give this one the IP 192.168.5.10 and this one the IP 192.168.6.10. This is /24. This is also /24. Now, when I say that this is /24, it means it is n.n.n.h. Correct? This one is also n.n.n.h. But this is something which we can understand. How will my PC understand this? My PC will understand this through something called as subnet mask. What is subnet mask? Subnet mask will help the PC understand the distribution of network and host bits. Subnet mask is the value which my PC will use to understand the distribution of network and host bits. So when I say I have 3 octets in network, that means how many bits? 8 plus 8 plus 8. That means 24 bits in the network side. And when we talk about network bits, they are always 1. So network will be represented with 1 and host will be represented with 0. Right? So some of you must be aware that bits are either 0 or 1. Now if it is network bit, it will be represented with 1, then host, it will be represented with 0. Now we have learned that each octet is having how many bits? Let me know in the chat. How many bits are there in one octet? One octet, not the IP, guys. I'm asking about one octet. 8 bits, right? And there are 4 octets, so we can say 32 bits in the IP. So when we talk about these 8 bits, they have some values. 2 raised to the power 0, we started using this master formula 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 3, 4, 5, 6, and 7. So don't worry, guys, this is not going to be a mathematics class, but yeah, some of calculations are required in IPs also. So 2 raised to the power 0 is 1, 2 raised to the power 1 is 2, 2 raised to the power 2 is 4, 8, 16, 32, 64, and 127. That's the only maths which you need while playing around or while working with IP addresses. If you are able to remember this table, that means you are done with the IP networks. You can perform any kind of subnetting. You can perform any kind of calculations related to IP addresses. Yeah, sorry about this. This is 128. Thank you. So these are the 8 bits of your octet. This is my first bit, second, third, fourth, fifth, sixth, seventh, 8 bits, right? If I keep all the bits as 0, let's see what do we get. If I keep this as 0, 0, 0, 0, 0, the final outcome is going to be 0, right? What if I keep all the bits as on? That means 1. So 1, 1, 1, 1, 1, 1, 1, 1. If you plus all these values, if you add all these values, you will get to know that the maximum you can get is 255. So if you keep all the bits as off, that means 0, you get 0. If you get all the bits as 1, then you get 255 as the maximum value. Guys, this is the reason why my classes start from 0 and ends at 255. Like we all must have thought of this, that why is it just ending at 255? Why can't we take it to 300? Why can't we take it to 400, 500, 600, right? This is the reason. My octet cannot have a value more than 255. That's why the range begins from 0 and ends at 255. So we have learned this is the reason, right? Now we will try to convert our IP addresses into bits. This is called dotted decimal form, which we observe, dotted decimal to binary conversion. Very easy, very simple. We just need to understand how to put the values into the table which we have just learnt about, these 8 values. What is your dotted decimal form? This is your dotted decimal form. But when you convert it into 0, 1, 0, 1, all such values, you call it as binary form. So let's get started. Let's try to see how we can do this conversion. Let's say now we will pick up the IP address from the previous examples only. Let's take this one, 192.168.5.10. We will try to convert this IP into the binary form. What do I need, guys? I just need those 8 values. That's it. So 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 3, 4, 5, 6, and 7. 128, 64, 32, 16, 8, 4, 2, and 1. So the IP which I want to convert into the binary form is 192.168.5.10, right? So what I need is I need to pick up the first octet and convert it into the binary, then the second octet, then into binary, like that. So what is the value of my first octet? 192, right? I need to find a combination which can give me the outcome as 192. For example, when I kept all the bits as on 1111, I got 255 there, right? I need to find out what number of bits should I keep on so that the outcome can be 192. So let's try to do this calculation. If I keep the first bit as on, it will be 128, right? If I keep the second bit also as on, what will I get? 128 plus 64. Let me know what is 128 plus 64. It is 192, correct? So when I have got my value, what I'll do is I'll put all the remaining bits as off bits. So 0, 0, 0, 0, 0, 0. That's it. And congratulations, you have finally converted the value of your first octet into the binary. Now we will move to the next octet, 168. For 168 also, I'll keep the first bit as on, that is 128. If I add 64 to it, it is 192. So I will not consider this one. I'll put a 0 there. If I take 32, 128 plus 32, 160. After 160, what do I need? I need 8. So 16 also I'll put as 0. So 8 will be 168, 0, 0, 0. I get 168. Now tell me about what will happen for 5. Should I consider the first one as on? No, right? That's very high from 5. So 0, 0, 0, 0, 0. 4 I can consider. Then if I add 2 to 4, that will make it 6. So again 0. If I add 1 to 4, it will make it 5. We have got the outcome as 5. Now last octet is 10. So 10 is simply 8 plus 2, right? 8 plus 2 is 10. So I can simply say 0, 0, 0, 0, 1, 0, 1, 0. This gives me 10. Easy, right? Do you guys have any questions regarding this? Let's look at one more example. This time we
And
will
also,
take the IP. Yes,
Yeah,
Dipanshu.
sorry, Chirag, just to cut you off 1 second. Guys, whenever you will be coming into the live class, you will have option to unmute yourself, present your screen, ask a lot of doubts, and things will move differently in a live class. Since a lot of people are here in the demo class, we are not repeating this even session also. So just wanted to point it out to everyone. Once you're in the live class, there you can ask for repetition as well from Chirag or Jatin or who is the instructor for you.
Correct.
Please
Absolutely,
continue,
guys.
guys.
So,
Please continue.
yeah, thank you, Dipanshu. So, as Dipanshu mentioned, like things will be a little different in live class. In live class, we will also not have any limit of timings. So, you will also get time to try out some questions. It will be a little interactive, more interactive, because you will be able to unmute yourself and ask your questions there. So, keeping those things in mind, let's move ahead and let's look at one more quick example. This time we'll take a IP from class B. So 172.16.5.7, let's say. Now this is my IP. I want to convert it into binary. So same thing. Those 8 values, that's all what I need. So 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 4, 5, 6, and 7. 1, 2, 4, 8, 16, 32, 64, 128. The first octet we have is 172. Guys, quickly let me know, what do you think would be the appropriate combination for 172? Let me know in the chat box. I'll give you 2 minutes. Now, we can't 128 plus 64 will be 192, not 172. Think about it again. 128 plus 32 plus 8 plus 4. Okay, let's see. If I take 128 plus 32, that is 160, right? 160 plus 8, 168. 168 plus 4, 172. Absolutely correct, guys. This is how I will get the outcome as 172. Similarly, if I want 16, 16 is very easy. We have a direct value for that. So we'll say 0, 0, 0, 1, 0, 0, 0, 0. This is 16. Then we have 5. 5 we have already tried. That is simply 4 plus 1. So 0, 0, 0, 0, 1, 0, 1. This gives me 5. Lastly, we have 7. What is 7? 7 is 4 plus 2 plus 1, right? So 0, 0, 0, 0, 0, 1, 1, 1. This gives me 7. And I can say, if I write all these bits together like 1, 0, 1, 0, 1, 1, 0, 0, dot triple 0, 1, 4 times 0, dot triple 0, then double 0, 1, 0, 1, and lastly 5 times 0, then triple 1. So this basically is my binary conversion of the IP 172.16.5.7. And guys, now you are prepared to convert all the IP addresses, any random IP address, into the binary form. Now let's talk about the subnet mask, which we were discussing earlier. So we said that, like if I talk about this scenario, we said that subnet mask is something which helps the PC understand about the network and host distribution. Correct? The bits of network and host section. Network bits are represented with 1, host bits are represented with 0. Okay. Now I have a network 192.168.5.1/24. This /24 represents the network bits. And I said that network bits are represented with 1. So what does that mean? 1, 2, 3, 4, 5, 6, 7, 8, dot 9, 10, 11, 12, 13, 14, 15, 16, dot 17, 18, 19, 20, 21, 22, 23, 24, dot. Now I have host bits which are represented with 0. So 0, 0, 0, 0. Can I say this will be the conversion? Right? Now I need to convert this binary into dotted decimal. So I want to convert the binary to dotted decimal. What do I need? Again, the same 8 values. That's all. So 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 3, 4, 5, 6, and 7. 128, 64, 32, 16, 8, 4, 2, and 1. So we have all the 8 bits as on, or we can say 1. So we can say this is something which I'll get. So tell me, what will be the outcome if I keep all the bits as on? 255, right? That's the maximum. Similarly, for the second octet also, the value will be 255. And this will be 0. So guys, this is what your subnet mask is. So what is your subnet mask here? It is simply 255.255.255.0. As simple as that. Similarly, for class B, we say that we have how many bits in the network part? 16 bits and 16 bits in the host part. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 0, 0, 0, 0, 0, 0, 0, 0, dot 0, 0, 0, 0, 0, 0, 0. This will be 255, this will be 255, this will be 0, this will be 0, and that becomes your subnet mask. Now tell me, what will be the subnet mask for class A? In class A, we have 8 bits in the network part. 8 in the network part and 24 in the host part. What should be the subnet mask for class A, guys? What do you think, guys? Okay, we have got one response, 255.0.0.0. Yogi has also shared the binary conversion. Absolutely correct. So absolutely correct. For the 8 bits of network, the subnet mask is going to be 255.0.0.0. So Yogi, when I ask you to mention the subnet mask, you will not give me the binary bits. Rather, you will give me the value like 255.000 and 255.255.00 like that. Yeah, sure thing. So what I'm saying is that when we have learned about all the 3 classes, like if I talk about IP address, the classes are 5 in total. But for public use, we just have class A, class B, class C. And the default distribution of class A is 8 bits in the network part and 24 bits in the host part. For class B, we have 16 bits in the network part, 16 bits in the host part. For class C, we have 24 bits in the network part, 8 bits in the host part. Correct, guys? Now, if I have, for example, we right now are talking about class C. If I have 24 bits in the network part, which are represented with 1, so what will be the conversion? This will be my conversion, right? These are the first 24 bits which I will keep as on, and then the last 8 bits which are for host part, those will be considered as 0. If I keep all the bits as on in any octet, the maximum value I get is 255. So 255 for first octet, 255 for second, 255 for third, and 0 for the last. That becomes your subnet mask for class C. Similarly, for class B, we have 16 bits in the network, 16 in the host. That means 8, 8, these are 16 bits of network and these are 16 bits of host. So again, 255 for the first one, 255 for the second. Hence, your subnet mask will become 255.255.0.0 like this. Senzo, is it making sense now? Similarly, for class A, we just have 8 bits in the network part. That means the first octet, so 255.0.0.0, like that. Great, awesome. So these are few things which we had to look into to basically get the idea about how different networks work, or how we identify whether the IP belongs to the same network or different network. Now, again, as we have already mentioned, this is just a demo. So that's why it might be a little I mean, it might require you guys a little time to grasp things, because you will be doing a lot of practice when you will be in the training session. But since this is just a demo session, so I'll quickly show you a quick example of how router is something which helps us in making two different IPs communicate with each other, which basically belongs to different networks. So what I am going to do is I'll take a PC with the IP 192.168.5.10/24 and the other PC 192.168.6.10/24. Okay, so first I'll try to connect them together directly without any router or switch. When I connect them directly, I will test their communication, and since they are not from same network, they will not communicate. But then after that, I will connect them through a router like this. This will be my router. Now, what is router doing here? Router will forward the packet from one network to the other network. This is the capability of router. So my router will receive the packet from PC A and will give it to PC B. And then I can say this communication will be successful. But for that, my router also needs IP address. So on my router, there will be something called as interface. Interface is where you connect your cable. So one IP will be required on the PC's interface, and one IP will be required here on the router's interface. Similarly, one IP here on the PC's interface and one IP on the router's interface. Now, from this network 192.168.5.10, if I talk about this network, then this network is starting from 192.168.5.0, and the maximum it can go is 192.168.5.255. This is the range of my network. This is the maximum value which I can get in my octet, right? And I cannot modify the values for these 3 bits or these 3 octets, right? Why? Because if I change any value in these 3 octets, then this will become a whole different network, which we don't want to do here. So this is my network here. The first IP of my range 192.168.5.0 will be called as network ID. And the last IP will be called as broadcast ID. Now, what is broadcast ID? What is network ID? How we use them, we will talk some other day. As of now, just understand that you cannot put these two IP addresses on any PC or on any router. So either you can put 5.1 or you can put 5.254. So these are the only usable IP addresses. So whatever comes between these two IP, 5.1, 5.2, 5.3, up to 5.254, that is what you can use on devices. So what I will do is I will put the IP 192.168.5.1 on my router on this interface, and 192.168.6.1 on this interface. And then we will see whether this communication works or not. So let's get started. Let's see how this will work. I'll open Packet Tracer and I will share my other screen now. Okay, I assume that my screen is visible. So please confirm that whether you guys
Yes,
are
it's
able to
visible.
see it. Yeah.
Yes, it is
Okay,
visible, Chirag.
so this is Packet Tracer, a simulator where you can perform your networking labs. And we have various devices here. I'll quickly show you what all things are possible. So we have multiple series of routers, we have switches, we have multiple other devices. Hubs are there, we have wireless devices. Then if I go to next category, end device, so you can put PC, laptop, server, printer, all such things into your topology. So I will take one PC, I'll put it into the workspace like this. Click on it and put it here. Then this is the section where you can do cabling. I'll select the cable, connect my PC0 to PC1. But wait a second, we haven't given any IP on these devices. And as per our discussion, we are supposed to give 192.168.5.10/24 on my PC 0, and then 192.168.6.10/24 on my PC 1, right? So let's see how this IP can be configured. I'll go to my PC 0, click on it. Here you get to see this tab called desktop. Click on that tab. This is the first option, IP configuration. Click on that. IP address. We can write down the IP which we want to configure. 192.168.5.10. I have typed the IP address. Now observe this, guys, very clearly, that when I click outside, the subnet mask automatically fills the value 255.255.255.0. So this is the default subnet mask of my IP address, which I can see is automatically filled here. You can change it if in case you are willing to do some sort of subnetting. Then similarly on PC1, I'll go to desktop, IP configuration, 192.168.6.10. And if I click outside, we have 255.255.255.0 as the subnet mask. Now we have connected the cables, we have assigned the IP. Now it's time to check whether these two devices can communicate or not. So first way of checking it is by using this option, which is provided by Packet Tracer. And you can click on first PC, then on second PC, and you can see the results of communication here. It is saying that it is failed, right? Why is it failing? Because these two are from different network. Or otherwise, what you can do is you can use the ping tool. Ping tool works on the protocol ICMP. Now, what is ICMP? What is ping? How is it used? We will be discussing all that in detail in the training program. So as of now, I'll just show you how ping works. All you need to do is you need to click on PC, again on desktop, command prompt, and you will say ping. And then you will put the IP of your PCB, which is 192.168.6.10. Hit enter. If you get a reply there, that means the communication is there. If you get some error message like this, request timed out, that means they are not able to communicate. So as of now, we are pretty sure that they will not communicate because they belong to different networks. And when they belong to different networks, which device do we use, guys, to make them communicate? Switch, right? Switch, router, what is it? As of now, I can see they cannot communicate. But if I want to build a communication, I need a device, which is a router, right? So what I'll do is I'll go to the section of network devices. I will pick one router. I'll place it here. Then I will remove the direct connectivity between my PC0 and PC1. I'll delete this cable. This time I will connect it with router and then to PC1 also, like this. Now, in order to make PC0 and PC1 communicate, I need some IP on my router. So 192.168.5.1/24 here, 192.168.6.1/24 on the other interface. This interface is FA00. This interface is FA01. FA stands for Fast Ethernet, which is a type of interface which provides you with the bandwidth of 100 Mbps. So let's go on to the router. Now this router can be configured through the CLI commands, or when you are using Packet Tracer, you can also configure it through this config tab. So in the training, we only use CLI. We don't use this config tab, right? But as of now, since we don't have the understanding of CLI commands, I will put the IP using the config tab. I'm repeating that in my training, I will never use config tab. I'll always use CLI. But for using CLI, you need to work on some commands, which we will be discussing in the training. So as of now, we are using the config tab. I will go to interface fast Ethernet 0/0. You can see here, click on that. We have this section of IP address. Put the IP 192.168.5.1. Then we have this section of subnet mask, which appears automatically. Then you can also see what commands would be required. This is how this packet tracer works. So even when you are just doing the configuration from this config section, then also you can read the CLI command. So these CLI commands would be required to make this configuration. This configuration is done. I can click on to make the interface up. And you can also see here that the red triangle now is changed to green. Similarly, I'll go to FA01, fast Ethernet 01, put the IP 192.168.6.1, and the subnet mask will appear automatically, then on. Close this. That's not all. Now I need to tell my PC also that there is a gateway. For my PC, whenever my PC wants to communicate with a different network, it needs a gateway. So I need to put the IP of my gateway here. For PC0, the gateway will be router 0's FA00. So what is the IP for FA00 on router 0? The IP we have configured is 192.168.5.1, correct? So I will write this IP here, 192.168.5.1, telling my PC0 that this is your gateway. Similarly, on PC1, I'll go and will set the gateway IP as 192.168.6.1. We are done. Now it's time to check the communication. Again, we will pick a packet and we will send it from PC0 to PC1. First time it might get failed, but the reason behind this is a protocol called ARP. ARP is something which we use for checking the MAC addresses of destination. So again, that requires some sort of discussion, which we will be doing in the training. But just understand that the first few packets might fail, but after that, it will work fine. It will become successful. So if I retry this, there you go. It is successful. Similarly, if I try to use ping, the ping command, so you can see that we are receiving the replies. How is that possible? That's possible because of my router, the layer 3 device, which is capable of sending packet or traffic from one network to the other network. That's how this whole networking works. And this is the same concept which we will learn at various details or at various depth in multiple types of routing protocols or in multiple scenarios. This was a very basic and very small lab with just two devices and a single router. But in the training program, we talk about big topologies. We also learn how to configure routers like 4 5 routers and multiple end devices, then making it more complicated. That thing we discuss gradually. Once you are good with the basics, then only we jump on to such things. But yeah, this is the basic thing, and I hope the basics are clear to you all. If in case you have any queries or doubts, you can let me know in the chat box, or otherwise you can raise your hands also.
So yeah, Ravikant, you want to ask something, Yogi? Let me just give you the access to unmute yourself. You can ask your queries. Yeah.
हेलो सर, आई एम रविकांत।
Hi Ravikant.
सर, मैं ये पूछना चाहता था कि राउटर से मैं पीसी 0 और पीसी C1 से कनेक्ट किया राउटर को, तो मेरा दो अलग अलग आईपी एड्रेस है, तो वो कम्युनिकेशन हो पाएगा या नहीं हो पाएगा? थोड़ा समझ में नहीं आया हमको।
देखो, अभी आपने PC0 को राउटर से किया एंड PC1 को भी आपने राउटर से किया, राइट? And then
Yes,
when
sir.
we have tried this communication, it is telling us that it is successful. So it is possible, right? That communication is getting successful. That means the exchange between PC0 and PC1 is there.
मतलब हो सकता है ना सर?
Right. It is possible and it is happening right in front of us.
ओके सर।
Right?
जी सर।
So we have another question that 10 dot something 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 slash 24 is a correct IP or not. Yes, absolutely it is a correct IP, but we haven't discussed any example related to such things because we still have to discuss the subnetting section. So that's again requires a lot of time. So we will not touch that topic right now. The gateway allow the different IP address to communicate. Absolutely correct. The gateway or my router, the layer 3 device, is helping me in order to send the traffic from one network to the other network.
Padlochan, I've given you access to unmute yourself. You can unmute and ask your question also.
सर लॉन तो होता है ना, लॉन में राउटर जरूरत होता है लोकल एक्सेस नेटवर्क में।
So you are
लोकल
asking that
एक्सेस,
whether we need router in a local area network or not, right?
राइट।
See, when your devices are participating in the same network, you don't need a router. When I have two devices which are in same network, all I need is I need either a switch to connect multiple devices. Let's take, rather than two, I'll take three devices. And in order to connect them together, we use a device called switch. Switch is a device which we use for connecting multiple devices together. So we will connect all the devices on switch and we will put them into the same network. So let's say 192.168.1.1/24 for PC2,
ओके
168.1.2/24, 192.168.1.3/24. Now you can see that all the three devices are in same network, right? So we don't
ओके
need a router here. If I put the IP addresses, if I go to desktop IP 192.168.1.1,
पर सर
then
वाइड एरिया नेट वन में इट इज मैंडेटरी और नॉट?
sorry, what?
वाइड एक्सेस नेटवर्क में इज इट मैंडेटरी?
Wide area network.
यस।
Yes. So when we talk about wide area network, it is connecting, we can say, two locations which are geographically at a different position. Like you are connecting India with Dubai. So India to Dubai connectivity is never possible without routers. So you definitely need router in such a setup. But when I have a small office, let's say I have three PC at my home and I use them together to work on some project. So do I need a router there? No, I can just simply put these three PCs into same network and after that they will communicate. Like if I try to send some packet from PC2 to PC4, it is successful, right? Even without router. Why is it successful? Because it is in the same network. And when the devices are in same network, we don't need router.
ओके
I
ओके
hope
गॉट
this
इट।
is clear to you now.
यस यस
Yeah.
गॉट इट।
Yes, Yogi, you can unmute yourself and let me know your question.
सर मैं ये पूछना चाह रहा हूँ कि ये जो सिस्टम है ये क्वारंटाइन में क्यों जाता है?
Yogi,
सिस्टम आई थी
please repeat
क्वारंटाइन।
yourself.
सर चैट बॉक्स, हेलो, कैन यू हियर
Yes.
मी सर?
Yes, Yogi.
सर ये पूछ रहा हूँ कि जो सिस्टम है वो क्वारंटाइन में क्यों जाता है? सिस्टम का आईपी क्वारंटाइन क्यों जाता है?
Quarantine, I didn't get your question, sorry. So
योगी ने
सर
चैट में भी
लोकल
लिखा है. Yes, Isenzo, you'll be able to ask the question. Just raise your hand once. Isenzo, I'll just unmute you. Okay. Meanwhile, let Yogi ask his question.
yeah, Yogi, please type your question in the chat box.
किया है उसने. He has typed there. What is quarantine system and why? I think spelling शायद वो है quarantine if he's asking something related to.
यस सर।
Hello, sir.
Are you just a second, Senzo, just a second. Let me just quickly answer Yogi. So are you asking that why is it like this in this format? Yogi, is that your question? Like why is it 192.168.1.1?
नहीं यार, I'm not able to hear Yogi. Yogi, can you please explain your question in the chat once? Meanwhile, Isenzo, you please ask your question.
Yes, Senzo.
Hello, sir. We have different types of devices like router, switch. Where do we use the hub? Because most time I come across the hub device. In which case we can use the hub?
See, hub used to be used when switches were not there in the environment, or we can say when switches were not in the picture. Hub was a device which was, we can say, a dumb device. It used to broadcast everything. Now we have got a better device called switch, so we don't get to see hubs nowadays. But hub is somewhat like a switch only, which is used for connecting multiple devices together. But there are some, we can say, differences between them. That is, like, hub always broadcast, it's just going to have a single broadcast domain and a single collision domain. But when I talk about a switch, switch is going to have multiple collision domains and a single broadcast domain, so it makes it a better one. It has its own memory, so it can remember the MAC addresses. So such differences are there, and because of that, we have already moved to better devices called switch, so we don't get to see hubs nowadays. So you have a question here, that we have a question that is like, if we have different networks and different premises and the connectivity is not established, so what are the parameters to check? So the very first thing you can try is you can send a ping message. If the connectivity is not established, so that simply means your ping will not work, right? You will not receive any reply because you don't have any connectivity. But in order to build that connectivity, you need to put the routing configurations like static routing, like EIGRP, OSPF, RIP, which we will discuss later on in the training program, as it is a lengthy topic to discuss. So that's something which we do to make that connectivity possible. Okay, so we have a question here from Yogi. What will happen if we have more than one PC with the same IP address? First thing, it is not possible. Second thing, if something like this happens, then you will basically get errors of overlapping IP address and the communication will not work there. So you will have to fix that to make it work. Yes, that's a scenario of having a duplicate IP, and that's going to make troubles in your environment. So you should never have the same IP on two devices. Yes, any other question, guys? All right, I think we are good. And yeah, so I hope I
Perfect.
was able to explain you the basics of how the communication works in the networks. But as I have already mentioned a couple of times, this was a demo session, so we had a limited time period. And we will be having a lot more examples and a lot more discussion on these things when you get to see these things in the training program.
I think Ravi wants to ask a question. Ravi Khan. Ravi Khan, you can push your question. No problem. Aftab. So it's okay. Yeah, absolutely. After once you're in the live class, you'll be able to understand 100%. Don't worry. You can ask for the, even for this one, if you're connected to one of our teammates, so you can ask for the recording of this session also. Don't worry. And you can learn this also 100%. Okay. So Yogi, duration of this course, CCNA course would be, if you're going for a weekdays 8:30 p.m. night batch, it would be 4 weeks to 5 weeks maximum. If you're going for a weekends batch, which is 9 a.m. every Saturday and Sunday, it would be 6 to 7 weekends. Malab, you consider 1 month to 1.5 months at least. Okay. Uh, there's a technical question here, Chirag, if you can answer.
Sure. Yes, Senzo, we can definitely make class A communicate with class C IP address, but again, that communication would require the layer 3 device called router. So that is possible and can be done easily.
I think some more hands were raised out. Padmlochan, do you want to ask anything? Ahia Senzo, do you want to ask anything? Guys, if anybody would like to ask anything, you can stay. If anybody else who wants to leave the session, they can leave the session. That's fine. आप लोग जिससे भी connected हो, if you're connected with anyone in our class in the PyNet Labs, you can feel free to connect with them offline after this session also. Okay. You can ask your doubts, you can ask your queries related to 100% job guarantee program or related to placements or related to, demo sessions and everything that is also available. Meanwhile, Asenzo, please go ahead and ask your question.
Hello, sir.
Yes, hi
Yeah, yeah,
Senzo,
yeah.
we can hear you.
Point of concern I want to ask. Now, for in certain areas like the ISP company, they deal with public IP address, while in some office deal with private IP address because of securing of information. How best how best can you allow both of these two IP address communicate or passing a particular data, like the private, like class A, the private, and class A, the public? How can you allow those two to communicate, sir?
Senzo, sorry, your voice was not very much clear, but I have got the understanding that your question is that why are there different classes and what is the difference in the public and private IP address. Is that correct, Senzo? Please confirm.
Yes, sir. That is my question. Then how is that possible for both class, for the public and the private to communicate when they are in class A?
Okay. Okay. So see, when we talk about private classes, the private IP addresses, these are free to use. These are used in the LAN networks. And now my LAN, let's say 5 PCs, these 5 PCs, these wants to communicate with internet. This is where I would need a connectivity with public IP. Now that requires some sort of configurations like network address translation. That's again a topic which requires a good amount of discussion. So we can say that NAT is something which helps us in such type of scenario where you make your private IP addresses communicate with the internet using a public IP.
Pradeep, overall, this class is ending now. Okay, the topic is over. If you have personally any questions, if you're connected to anyone in the team, that is good. If you're not connected to anyone in the team, you can raise your chat here at pynetlabs.com. Somebody from our team will connect with you immediately and help you out tomorrow morning. Okay, for any questions, anything you want to ask. Okay. I think Padmalochan has raised his hand. Padmalochan, do you have any questions? Okay, I think he has raised his hand mistakenly. No problem. Hi everyone. So anybody has any other questions? You're most welcome, Pradeep. You're most welcome, Yogi. Uh, I hear you want the work examples. Can we have the note and work examples? So yes, all the what do you call the lab workbooks and examples are shared in the live classes whenever the live classes will be starting next week, Monday evening. You can ask in that session. Aya, you are connected to somebody in the team right now? All right, Pradeep. All right, Avikant. All right, Aftab. Good night. Tata. See you. All right, Aya. So if you're not connected to anyone, you can just go to this website. I'm just giving you the website in the chat box. You can fill the form, and somebody from our team will connect back to you within maybe 24 hours, maybe tomorrow morning only. Okay. You're most welcome, Veera. Chirag, I think Chirag, we can wrap the session for today, and we can prepare for more sessions that we have tomorrow.
Sure.
All right,
Thank you,
everyone.
guys.
All the best.
Yep.
Yeah. Thank you. I think Aftab is raising hands. 1 second. I'm allowing him mic. Aftab, you can unmute yourself and ask your questions.
Hello.
Yes. Hi, Aftab.
Good morning. Good evening, sir. It's not morning.
Yes. Good evening. What is your question?
The question is, well, I don't have that much of a great question, whatever they ask. I have a simple question like, what is the good for attending a class? I cell phone or laptop?
It
Laptop
is
only.
always better to connect through a laptop because we will be performing labs, and in the live sessions, I'll be providing you time to perform the lab. So you can do it only on the laptop. So it's better always to connect through a laptop. And I'll also right away mention the requirements. So all you need to run for your CCNA program is this packet tracer. This is a simulator which can work on very minimal configurations also. So any laptop with 4 to 8 GB of RAM will work.
I have a gaming laptop. Is it good for this?
Sorry, what?
Gaming
I have
laptop. Yeah, that will work. That will definitely work. So I think that has 16 or 32 GB RAM, right? Or more than that. That's very good. Don't worry about it.
How come? How some of after this packet tracer, so use it
Sure.
to practice? How come?
Aftab,
What,
you're asking
Senzu?
something? I think Senzo, you're saying something?
Okay. There's something. Just one.
Senzo, actually, your mic is very distorted. Can you type in the chat box, please, Senzo? We'll answer you in the chat box. Yeah. All right. Guys, if you have any questions, you feel free to put it in the chat box or you can put it to our team. And if you do not have any question, it's okay. You can leave the session now. All right, Ravikant. Bye bye. Tata. See you. Thank you. Good to know that आपको अच्छा लगा. Good to know, man. Thank you.